So the second slide.
Okay.
Yeah, so that's just to show the structure of our institute, Institute of Networked Energy Systems in the north of Germany. So the box in green is the group that I lead, which is part of the energy system analysis department. And there are other also departments would deal with different aspects of energy research. So if you move to the third slide, that's a little bit of information about what we try to achieve in this research group. And as highlighted by all the speakers before me, the issue of data and models which are needed to be transparent and also accessible. And that's one very important part of this research group. We try to develop open energy system models for the interconnected energy system. That means that we're looking at different sectors, and we try also to develop open data models based on GIS technologies and make them available to different stakeholders. The second main part of the group is actually to conduct ourselves energy system optimizations with a focus on the power network, but also including sector coupling and the potential development of different flexibility options. And also to look at the design and evaluation of energy system concepts and design. You can see at the bottom, we do that at different scales, from transnational to regional and urban scale, using those models and data we develop ourselves. So if you can move to the next slide, I'll show an example of one of our project highlights, which is the SciGrid project, which stands for scientific grid. So what you see are two different representations of data, which is available on a database called OpenStreetMap, which is like you usually Google map, but with the difference that first, this is data generated by the public, so mapped by the public and sent to a database, and with also the different that the underlying data that you see is available and one can download it and use it under an open source license. So on the right hand side, you see the data available for gas network in Europe with the different elements of a gas network. And on the left side, you see the available data for the power sector. So also pushed by the same issues that the speakers highlighted, which are the lack of data for the power sector, we started a project. If you can move to the next slide. This project, like I said, is called SciGrid Power. So we started the project in 2014, and our goal or motivation was to provide robust data sets and models, so data models for the European transmission power grid, and actually to do the job that a lot of groups don't want to do because it's costly and also asks for resources. So we wanted to do the job for once and actually make this data available for everyone, so everyone can profit from such initiative. So like I said, our objective is to develop an open source and open data model to provide the data, also the tools that we use and the documentation free and under open source license. And also we want to direct it not only to commercial use, but also more on the scientific analysis side to allow for comparison, validation, and also for results dissemination. And we saw how much important it is to be able to compare or to have a holistic view of modeling, so that later on comparing results is made easy as we maybe use the same input data set. So if you move to the next slide, so give you just a very short idea about how the project itself works. So we have three main aspects. The first one is, like I said, the data aspects, and our main source for data for the power sector was the OpenStreetMap data set. And we take this data set for a certain region. And then on the second part, we have our model itself, which post-process this data set. As you can imagine, is a huge number of data that can be found in this database. For Europe, for example, it's around 30 gigabytes. And then we take this data and we build a model for the electricity network. So how the electricity network should look like in our model is a collection of substation, electrical substations, which are connected by transmission lines. And based on this definition of the model, we use the data, the bulk data that we downloaded, we filter it for those elements, and then we connect those elements based on assumptions. These assumptions are based on the function and the composition of the transmission network itself. So that's the block you see in the center with the blue colors. At the end is the orange block, is actually the part where we document the data. We also offer tools to visualize the data, different format for the data, CSV files, for example, or also GeoJSON files, or even dumps for the data for the user that need to maybe post-process the data themselves. And all the documentation is available for how did we take the assumptions, which data did we download, what are the aspects of the modeling that we took are available, with the possibility also for the user to either use our data as such, or actually change the model themselves and adapt it to their situation. On the bottom, you see some of the applications for the data. So I guess the first application that people look at is to run simulations on the power network, but there are other different applications for such data. One of them is to validate, compare data with different data sets. So every user or every modeler has it or her own assumptions to develop their models. And it's interesting to see also how the network at the end looks like when we vary these assumptions. And also we created some conversion tools to allow people to use our data set for different power flow tools. If you move to the next slide, so the project itself is finished, and we made everything available on the web page. And like I said, some of the studies we conducted were to characterize the German transmission network, looking at clusters, which lines are very important in the network, and which lines could be, for example, extended, or what are the lines which are all the time overused, and how to alleviate that. Second, maybe a topic, like I said, is comparison of networks. If you have an old data set or a data set that was shared to you by an institution, and you have your new data set, you can use this tool to actually see the differences and make your job easy in the sense of actualizing your data set. And like I said, the third application is the most used one, which is the power flow simulations. So if you continue to the next slides, we did this for power network. We're doing it actually in a current project for the gas network. So we're trying now to make the gas network data set available for Europe. And maybe as a note, those methods that we developed, as they are open source and transparent, people can also adapt them to their own regions. So we tried also this exercise at some point, I think 2 years ago for India, in the context of a conference, and we showed also that some data is also available and can be used. So we did this for the power network, but we also do this for complete energy system models. So we also have developed in cooperation with different institutes that you see at the top, the University of Magdeburg in Germany, and also 2 research institutes, one in Berlin and the other one in Flensburg, an open source planning instrument. So the whole actually planning of the electricity grid, and this tool also cover the whole voltage level span, so from the distribution to the transmission, which is the highlight of this tool, and which differentiated from the tools which are normally either looking only at the distribution level or at the transmission level. And this tool offered also the possibility of conducting an economical optimization for the generation, and also for flexibility and network expansion. So to have an idea how to compare such flexibility options, and to take a deeper look in such issues as such, to should we extend the network, or should we extend our flexibility, or should we also invest more into storage? So this tool is also open source, and is also available, not only the tool itself, so the model, but also the data set. So we have built also an open energy database, which is backing up this model, and it's in a very modular fashion to allow people to do their own simulations, and also look maybe at only the distribution or the transmission, or look at both both voltage level. As you can see down on the bottom left, there are some figures for Germany for the potential for renewable energies. In the center, you could see a visualization of power simulation for the whole electricity network in Germany up to 110 kV, which is the link between the transmission and the distribution. In the next picture, you see the same simulation for a small distribution network. And then you could see also that one of the results, as you could expect, is also the share of different generation technologies into compensating for the load. And like I said, this is mostly based on for the German situation, but these tools can easily be extended to other regions as long as the data is available. If you move to the next step, yeah. So that's my, I guess my talk, and yeah, thank you again for giving me the opportunity to present that, and I'm open for questions.